Hello, today I'm going to show you how to balance a chemical equation. To balance a chemical equation, you need to follow the law of conservation of mass. What it basically tells us is in a chemical equation or in a chemical reaction, the amount of matter or of mass or of particles that you have before a reaction has to be the same as after the reaction, right? You cannot create matter out of thin air. Whatever you had before, you will also have after. And so whenever we have a chemical equation, let's say we have hydrogen plus oxygen combined together to form water. The goal of balancing a chemical equation is to basically follow this law, right? The purpose of balancing a chemical equation is to make sure that we have the same number of atoms before and after. Now, in order to do that, we can only use coefficients that can be written in front of our formulas, right? You cannot create a number, for example, that will go in between here. You cannot write a number that will go as a subscript, right? It has to be a coefficient that is written in front of the number, right? So if I wanted to write 5, I would write it like so. So how do we actually balance a chemical equation? Very good question. The first thing that we're going to do is we're going to make a list of all of the atoms involved. Okay, so number 1, we have hydrogen that's involved before and after, and oxygen. And then the second thing is we're going to take a tally of how many atoms we have before the reaction, so that means before the arrow and after the arrow. So you can see here we have a subscript of 2, so that means we have 2 hydrogens before the reaction occurs. And we happen to have 2 atoms after the reaction occurs. For oxygen, we have 2 before and we have 1 after. So we can see that there's a problem right here. This part does not follow the law of conservation of mass. Therefore, we're going to have to balance it. So, what would I need to do to create 2 atoms? Again, all I need to do is form a 2, or write a 2 as a coefficient in front of the formula, right? I would not be allowed to put a subscript over here, only coefficients. So by doing so, can you see that I have not only created 2 oxygens here to balance the entire number of atoms before and after of oxygen, but I've also created 2 times 2 hydrogens. So now instead of having 2 on the right side, I've actually created 4. Well, this is not good because on the left side, we have 2 atoms of hydrogen. Can you think of the remedy that would have to come on the left side? You guessed it. By placing a 2 or writing a 2 here, now you've created 4 hydrogens and your equation is now balanced. Let's do another example. Imagine that I have aluminum bromide added to chlorine gas, and it gives us aluminum chloride added to bromine gas. The same process is at play here. First thing you do is you identify all of the atoms that are involved in this chemical reaction. So we have first aluminum, we have bromine, and we have chlorine. Looking at what's before and after for aluminum, we see here there's no number on the left, so that would be just the same as a 1 and a 1 on the right. For bromine, we have 3 on the left and 2 on the right. And for chlorine, you can see 2 atoms on the left and 3 on the right. So we can see that the law of conservation of mass is not held together here. So we're going to have to verify that or to alter that. So the first thing we see is that in order for the numbers to be the same, we're going to have to find a multiple of 2 and 3. How do we find the multiple? Well, actually, the least common denominator will be found by just multiplying 2 times 3, which is 6. So that means that we want to have 6 bromines on the left and on the right. So let's start with the left. If we put, what number can we put in front here of aluminum bromine to cause it to make 6 bromine atoms? Well, if we put a 2, now we have 2 times 3 bromine would give us 6. But now we've also altered the number of aluminum to 2. So that means we have to amend that on the other side. Here, by placing a 2 over here, we now have rectified this number to 2 aluminum, right? But what have we also consequently created? You guessed it, 6 chlorine. So now we have 6 chlorine. So how do we fix that? Well, we can look on the left side. We have 2 chlorines already. 2 times what would give me 6? That's right. If I put a 3, I would have now 6 chlorine on the left side. And then last thing to rectify is the bromine. We want to have 6 of them, just like on the left side. We have 2. So 2 times what would give me 6? 2 times 3. And now we have balanced our chemical equation. I hope that this way will make it easier for you to balance chemical equations. Remember, the steps are this. Number 1, you want to identify the atoms involved in the equation. Okay, you can list them under the yield sign in the equation. Number 2, tally the number of atoms on each side of the yield sign. And number 3, use coefficients in front of your formula to balance the atoms on each side using, or let's say, to follow the law of conservation of mass. Okay? And then what you're going to do is you're going to cross out each number as needed until both numbers on the sides of the yield sign match. Sometimes you're going to have to do this multiple times. I hope this helps, and I will see you next time.